Great, thanks very much. Right, welcome back everyone. It's good to see you've all come back for the first afternoon. But this is where it gets a bit more serious for you because you now have to start doing something, all right, other than listening. I've got a few slides to give you some background context to the exercise, and then I want to introduce the exercise itself to you and what you're actually going to be doing, and I can give you some resources, and we're going to go into groups and do things like that. But let me just explain to you what you're going to do. So this is basically what the exercise is about. You're going to explore the effects of the new IPCC community scenarios, the so-called RCPs, SSPs, which I'll describe to you later on if you're not familiar with the acronyms, on future land use change in Europe using a regional integrated assessment model. Right? So that's going to be your exercise. So it's nice and simple, nothing too difficult there. So what I want to do now is to introduce you, first of all, to the model that you're going to be using, and then to the RCP and SSP concept, which is some of the data that will be used as input. So basically what we're going to do is we're going to give you the RCP climate change data. It's already uploaded into the model. What you're going to be working on is the development of the socio-economic development pathways and the inputs to the model, the parameter input values. Okay. Right, first of all, introduction. You're going to use a model called the Climsave Integrated Assessment Platform, that should say, or the IAP. All right. So this is, as I said, a regional integrated assessment model. So it's a range of coupled meta-models that cover a range of different land-based sectors. Okay, I'll explain what those are in a moment. So the model runs through a web-based interface. All right, so you can have access to the model through this interface. You can all access it simultaneously, and hopefully it won't fall over. And I'll show you the interface in a moment so you can actually see what it looks like. And that's the website where you can find the model, but don't go there just yet. All right? Just wait a little bit, listen to what I've got to say, because you'll have plenty of time to play with this model all afternoon, and all night if you want to. It's up to you. Right, so this is what the model does. So basically it covers these range of sectors. So we've got agriculture, forests, we've got coastal flooding and riverine flooding, there's water resources and water quality. It looks at a whole range of different species that collectively make up biodiversity, and it looks at urban land use as well. So it's covering the main sort of sectors in inverted commas. The point about this model, though, as with other integrated assessment models, is that we know that there's, for example, competition for land for these different types of activity. We know there's competition for water resources between these different sectors, and we know that there are indirect impacts of things like climate change through the impact of one sector on another sector. So basically there are lots of interactions, and this is what this model attempts to do. It tries to build those interactions and allows you interactively to explore the outcomes of different scenarios that you can build. Just in sort of general terms, again, as I mentioned, the model itself is made up of a range of individual meta-models. So there's a reason for that. Meta-models are basically simplified versions of a more complex process model. So there's a whole different types of methods that are used. Some of them are simple lookup tables, some are simple statistical emulators, some are just reduced form models. You've got neural networks that are used. It's a whole range of things. The reason for using meta-models and not the full process models is when you start coupling all of these different sectoral models, it gets very complex and it takes a long time to run the whole model. The whole point about this tool is that it's interactive and you can run the whole system in less than 2 minutes. Okay, so you can constantly go back and change the inputs and explore the outcomes. So that's the reason it's based on a meta-model approach. There's actually a version that runs for Scotland, but a version that runs for the EU 27 plus 2, which is Norway and Switzerland. And you're going to be using the European example in your exercise. Okay. These are just the different individual meta-models that are modeled and the connectivity between them. So it's very much a sort of cascade of flows of information between these meta-models. There's about 1 or 2 feedback mechanisms in there, but generally it's fairly sort of linear, step by step. This is what the interface looks like, and I'll take you through it again in a moment. So the whole thing is driven by these sliders. So if you want to change population, you just whiz that slider up and down, and hit run and you rerun the model. And you'll look on these tabs here. These tabs represent the socioeconomic settings, which are effectively the driver categories that I was showing you earlier. So you can look at a whole range of different things: societal preferences, demographics, economic development, etc. Actually, the up-to-date interface looks a little bit different from this, but that doesn't matter. And you can also run different climate scenarios as well. You could choose the time horizon. We're going to look at 2050. It's a time slice. You could choose the emissions scenario. This is based on SRES. I'll come back to that in a moment. You could choose different climate models, different climate sensitivities as well. And there are some predefined socioeconomic scenarios, but you're not going to be using those because you're going to be using the SSPs, which I'll explain later. But what you can also do is choose your sector from this list up here, and you get a whole range of different output indicators from the model, which you can then show on maps. Right? And you can download all your data as well, okay, to a spreadsheet. So that's basically what it looks like. So the scenarios you're going to be using, this is the heart of the exercise. So some of you, I guess, will be familiar with SSPs and RCPs. Yeah? Good. Is everyone familiar with that? Is anyone not familiar with them? Right, one, two, few. That's okay. So it's about half and half. That's fine. I'll just quickly run through some of the basic principles. But basically, the RCPs stand for the Representative Concentration Pathways, RCP. And they are associated with what are called the Shared Socioeconomic Pathways, or the SSPs. Right? So that's what the acronyms represent. And this is the sort of new approach to climate change scenarios that are being developed not directly by the IPCC itself, as the SRES scenarios were, but by the community of researchers who are involved in the IPCC process. So they're largely seen as a replacement for the SRES approach. Okay? So that's why it's hot off the press, effectively. That's what we're trying to do here. So the RCPs, they're actually more normative than exploratory, because what they're interested in doing is looking at sort of radiative forcing levels that lead to concentration pathways that lead to the radiative forcing levels. And they're defined, as you could see in the previous one, in terms of the watts per meter squared. So you've got RCP 2.6 watts per meter squared, 4.5, 6, and 8.5. So obviously the 8.5 has a higher radiative forcing, which leads to a higher range of global temperature changes, depending on other assumptions like the models, etc. So there's variability around that. So that's basically where we are. The forcing levels are projected out to 2100. And obviously, if you look on the graphic on the right, the different RCPs have different temperature ranges. Right? So going up to sort of 5 or even beyond 5 degrees, I think, in some of them. Okay, so they're basically there to try and span a range of uncertainty in radiative forcing. So that's the RCPs. You just need to know about that. We're not actually going to do anything other than you'll just use data for the RCPs, which I'll explain in a moment. What you do need to know more about is the shared socioeconomic pathways. So in the examples I showed you earlier of scenario development, we looked at the scenario logic, and I showed you some examples of a matrix-based approach. It's a little bit like a matrix, not exactly a matrix, but it's got 2 dimensions, as you saw there's other examples. And the 2 dimensions are socioeconomic challenges to mitigation and socioeconomic challenges to adaptation. All right? So basically, in an SSP5 world, so they're numbered 1 to 5, you have these 5 locations on the graphic here, would be a world where you just continue to emit greenhouse gases. There's no, you're unable, whatever, collectively in the world to reduce emissions. Whereas SSP1, you actually overcome the barriers to emission reduction. And likewise, SSP3, you both emit lots of greenhouse gases, but also your society is non-resilient, unable to adapt to climate change itself. Okay, so we've got those 2 dimensions. And within those dimensions, they've also been given silly names as well, if you want to use those. I tend to just use SSP1 to 5. Within those, there are also narratives that have already been written that describe those different future worlds. And we'll give you that information in a moment. I won't go through those narratives, but we've got some papers that you can have a look at. Right. The other point about these SSPs, and again, this type of information is held within in the paper I'm going to give you in a moment, but you can recast them in terms of different dimensions. So in this case, you're looking at economic growth against societal sustainability, or environmental sustainability against societal sustainability. So each of the SSPs are located in the different sort of dimensional space, depending on these different factors. So you can use this type of information to help you construct your own SSP. So what I'm going to ask you to do in a moment is, in groups, you're going to work on one SSP each group, right? So you can really get to know that SSP intimately. In principle then, what you have with the new scenario framework is a combination of RCPs, which give the radiative forcing level, and the SSPs, the shared socio-economic pathways. And you, in principle, can explore a whole range of combinations of individual future climates on the left-hand side against future socio-economics. And in fact, in the new approach, there's no definition of what socio-economic pathway should go with which climate. In principle, the argument is that all combinations are possible. In practice, they probably aren't. And for the benefits of the exercise here today, we're just going to choose one RCP to go with one SSP, just so you have time to do those runs. Okay. There we go. A bit more of that. Right, so now the exercise. How will land use change in Europe by 2050 in response to socio-economic and climate change? That's our focal question that we're defining for you. So I'm going to divide you up into 5 groups in a moment, and each group will work with one SSP. Okay, I'll explain to you how I'll do that in a moment. You're going to run the SSP through the Climsave integrated assessment platform, all right? And you're going to generate lots of indicators of land use change as outputs from that. And at the end of today, I just want you to very quickly present, each group to present back the results that you found from your analysis. We're just in 5 minutes, yeah? It's not a big presentation. It's important, though, that you do generate some results because you're going to use these results in your exercise tomorrow. All right? Is that right, Tom? You're going to be working all night running models with the data? Yeah. Okay, good. Step by step, just to take you through this is what you need to do, right? So first of all, you need to read your SSP storyline. So you need to understand it. Right? I'll give those to you in a moment, one per group. You need to explore the IAP modeling interface, and I'll show you that again in a moment, right? But just have a play around, get to know it. Then you have to go through a process of interpreting the input parameters to the IAP from your SSP narrative, from the storyline. And you could do that to start with in a qualitative way. So that might be, as I showed you a little bit earlier, population might be high, medium, or low, right? So that's just a qualitative statement. And I'll give you a paper, a copy of this paper, which has just been published in a moment by Brian O'Neill, just published in Global Environmental Change, which describes the SSP narratives. And there's tables in here which actually give that qualitative information for most of the variables you're dealing with, but not for all of them. So some you can do quickly, others you might have to think yourselves and do your own interpretation. You then, though, have to do another interpretation step, which is to go from the qualitative, high, medium, low, to the quantitative input values. And those are the values on the sliders themselves on the model, or sometimes they're check boxes. So you need to do that. You need to save the model, which you can do. I'll show you how to do that. You need to run the model, generate your outputs, and you can download the data to a spreadsheet and report back later on those results. Okay? Right. This is what I'm going to give you as well. We've got printouts of this. Okay, you can have some of these per group. So what I've done is given you a complete list of the important input parameters to the Climsave IAP, which are, for example, under the social category. These are the values that you'll find that there are sliders for, or checkboxes. So you can go through and first of all fill this out qualitatively. So as I said, is population change high, medium, low, or you can give it a 1 to 5 scale, or you can go plus, plus, minus, minus, whatever you want to do. But it's all qualitative. And then you go through and come up with a value. What does high population growth mean? All right? You might have to make some heroic guesses on this at times, right? What you will have, though, is the benefit of enormous wisdom that will come to you from the people sitting at the back, who are going to be sort of rotating around the different groups, myself included, and we'll try and answer questions, or if you're not sure about things. And of course, you're most welcome to use the internet, go online, find out what population projections are out there already, and use the spirit of those, right? So there's lots of ways in which you can do that. That's why you're in teams, because there's quite a few things to do, and you've only got one afternoon to do all of this, right? So there are different tables. You'll have all of this for the different variables, all right? So you need to complete those as best you can. and then you're ready to run your model. But the final step is you need to choose a climate scenario. Now, because the RCPs and SSPs are hot off the press, they're only now being quantified using models. So when the Climsave IAP was produced before that happened, so the IAP uses the SRES scenarios. However, there has been several studies, published studies now, which have attempted to map the RCPs onto the SRES scenarios. So what we can do is just use a simple analog for the purposes of this study, which you can see is down the bottom here. If instead of RCP 8.5, we can use the A2 SRES. RCP 6 is the B2 SRES, is the equivalent. RCP 4.5 is the B1 SRES. And those data are pre-loaded into the Climsave IAP, so you just choose it from a drop-down menu and you can do your runs. So the focus of your exercise is on the socio-economics rather than the climate, but the climate will have an effect on the outcomes. The other thing is just to to limit the exercise. Remember I showed you this table before. What we can do is quite intuitively is just to limit for each group to one SSP and one RCP. I propose to do it like this. I mean, if you want to do it differently, you're most welcome, but it seems like a logical way of doing it. Clearly, the two SSPs that have the highest challenges to mitigation are the ones that are going to have the highest climate change, so it seems reasonable to make those 8.5. The bottom one, SSP1 and SSP4, is the lowest mitigation, so it's going to have the lowest climate change, so it makes sense to be 4.5. I haven't done 2.6, because apparently that's just about impossible to achieve. It's implausible, based on current trajectories, frankly. So you have to do something really bizarre to actually get down there. And then the SSP2, middle of the road, we'll just put in between, okay? So that's just a little matrix so you know which SSP is going with which RCP, which actually translates into an SRES scenario in the model, okay? Got that? Good, we can always help you again. So there's some resources here, so you can go to the model homepage and have a look. There's also just recently published a special issue in the journal Climatic Change, which has about 10 or 12 papers all about the Climsave IAP and its applications, so there's plenty of background. I don't expect you to read all of that. There won't be a test later. And there's some other key papers that you might be interested in. I'll give you a copy of the O'Neill, and you can find the others online if you're interested in sort of general background to the Climsave project and to scenarios in general. Okay. Any questions on that so far? Right, okay, that's good. That means that everything is completely crystal clear and you have no problems whatsoever. Okay, when you go to the Climsave project website, it'll look something like that. And you will be able to go to the IAP tool. You've all got computers with you, okay? So assuming that you can all use your own computers for this, it's just a web page. You click on that, and it brings you to this page with a little bit of background information. There is a login. So to use the model, it's completely free, but you just have to register. That's just so the model developers have an idea of who's using the model and things like this. So there's nothing sinister about it. You have a login, you can hit start, and then you come to, because I've already done it, a screen that looks like this, okay? And again, I've done a run already just for the baseline conditions, but let me just quickly run you through the interface. You can explore this. It's supposed to be intuitive, right? And you're all used to using computers, so I'm sure you'll be able to work it out. But again, just to give you an idea how it basically runs, at the moment I'm on the economic tab here. So I've got things that relate to economics. I've got GDP change and change in the oil price, which is actually a proxy for energy prices. And you can use the slider, you can change that around, okay? And it tells you how much you've done. There are tip tools which explain what each of these parameters actually mean in practice. And you can go to social, and you can change population, water savings due to behavioral change, dietary preferences, right? There's a whole range of things that you can change here as part of your scenario. I mentioned that also there are the time slice. We're going to work with the 2050s. It's a time slice based model rather than being a transient model. We'll work with the 2050s. And at the moment, you can use these menus to choose your climate scenario based on the combinations I gave you earlier to be proxies for RCPs. There's about 5 or 6 GCMs in there. You might want to decide which GCMs you use. Some of them give hotter worlds than other worlds. So if you want to go for more extreme, you might want to choose a GCM that is hotter. We can give you some ideas about that. The climate sensitivity, again, if you want to be at the higher range of your RCP, then you could choose a higher climate sensitivity or lower if you want to be at the lower end. There are pre-programmed socio-economic scenarios in here which you don't have to worry about because you're going to do all of your changes relative to the baseline conditions, right? But you could use, if you want to explore what those scenarios are about, that might help you in terms of some of these settings. And what you'll see on here, actually, for those, just so you know, the green range gives what is thought of as being the credible or plausible range for that particular parameter, and the red ends give the maximum beyond which you shouldn't really go for that parameter because it's not plausible, okay? But you can change all of that. So there's technology tab, economic, etc. So all of the things you need to change are all in these, within these tabs. Joe? If you choose a socio-economic scenario, if you choose the baseline, it gives you the current value. So what I would suggest is don't worry about the socio-economic scenarios here. You can choose your climate scenario as defined, choose your baseline, and that gives you the current situation. So then anything that you do as your scenario is a change from now to 2050. Yeah, like a step change to a 2050. Is that okay? Then if we want to look at some of the outputs here, so this right-hand side gives obviously the mapped outputs and the legends. You can change the legend if you want, actually. You can look at the absolute values, but if you're running scenarios, it's quite useful to look at the relative value. Oh, so I haven't done a model run yet, so there's no data there. But the relative value gives the change to the baseline as a percentage. And again, you can choose from here a whole range of different sectors you're interested in, agriculture, forestry, whatever you're interested in. And you could choose a whole range of output variables, land cover types, crop yields, areas of different crops. So there are several indicators here that are basically land use indicators. You can look at urban areas, agricultural areas of different types of agriculture. You can look at forest areas, etc., and different types of habitat areas if you're interested as well. And again, you can also save your scenario. That saves all the settings in here, and you can load it up again if you want to, and you can export the data as well to a CSV file. Okay, so in theory, it should be nice and easy to use. I mean, it looks a little bit scary to start with, but once you start playing around, I think you'll find that you'll get there. There's quite a lot of help in the system here, so you can go to the help screen, which will tell you a little bit more about the models and other issues. I realize this is like a user guide, basically. I realize that for you, most of this is going to be quite black box, because you won't know what's behind the models, right? You're just running them. But if you want to know, I can give you some ideas about what the models are actually doing and how they're trying to do that if you're interested in asking those questions. Okay. But otherwise, I think we're ready to go. Is that sort of fairly clear as well? Everyone happy with that? I think you'll find once you get into it that it'll work much more easily. Right, I'm going to put you into groups now, and basically we want you to self-organize yourselves within the groups. So we'll just float around, giving you ideas, trying to answer questions. If you get stuck, don't be afraid to ask questions. But otherwise, you just organize yourselves and organize the work between you. So what you have to remember is that at the end of today, the last half an hour, I want you to come back and make your group 5-minute presentations. So obviously, that'll be a long 5 minutes if you haven't done anything and you've got nothing to present. Right? So just try and get some runs done. As I said, sometimes it may not be perfect in the time you've got available, but do as much as you can. And you can always run whatever values you've got. Tom? Great, thanks for that. So, and just finally, I forgot to mention that once you've set up your scenario within the model, if you scroll down to the bottom, there's a button cunningly called Run. I guess you can understand, what that means. And if we click Run, you'll get this screen. Don't get worried about that. Just click OK. This just gives you an option of choosing different species. The only reason for that is it takes a long time to run individual species models. So there's just a representative example here, but that's not the part of the model you're really interested in. It's running. Oops. in real time, this tells you each of the models that it's actually going through. It goes through an iteration. One of the models, interestingly, is a meta-model of LPJ guess, which is the model you're going to be using tomorrow. So there could be some interesting comparisons there, but we'll see. You can, as soon as it takes about 2 minutes to do a full run, okay? But actually, you can already look at indicators that are at the beginning of the cascade of integrated models. So I can already look at urban land use, artificial surfaces, the residential area, for example. I can look at the relative to the baseline changes, not very many, because it was baseline run, wasn't a scenario run. So you can start looking at all of these types of things here, yeah? A whole range of land use related indicators. Okay. And it's sort of pretty much just like that's just got to the end of the run, so that's how long it took. So it's probably 1.5 to 2 minutes. There we go. That's everything said.